Yes, thank you for the introduction. Thank you for being here today. So let's switch the topic a bit. Still, we have something that is moving, but now it's parking, and what do we do when it's parking? So we go into the topic of who's in charge of charging. So as a very short introduction, I'm here today to present for Kühne, who's first author, but who's not anymore here because she's left academia. But I'll do my best to present her first author work. And this is the rest of the team. You will see some more presentations during the conference from some of them. And yeah, we are working in the core on sustainable digital resource regulation with 3 main lines of research, lots of applied projects and 8 projects that go in this direction of sustainable mobility. And the project on the right side, on the lower side, is Co-Charge, which we do together with Honda Research Institute Europe, and that's the project I want to talk about today. And I want to start with a question, which is, what is the key challenge of the transition to green energy? And the answer is mainly it's storage. You can have more and more renewable energies in the grid, but then the question is, how do you store them for limited or longer amounts of time? And there may be an answer. For example, in Germany we have now we have over 1 million electric vehicles. And if you think about the average size of a battery of an electric vehicle, you could say right now we have a 50 gigawatt hour battery standing parked in at charging stations, or sometimes, but not very often, also moving over the streets. And that's basically the point where our project started. So, because electric vehicles can support the efficient utilization of renewable resources, but mobility needs or mobility patterns and the grid needs, let's anthropomorphize the grid. The grid needs may not align at every point in time. So let's put some entity between. So a smart charging agent may offer the potential to integrate these needs of grid end users. And so to go to the left side, the challenge that we wanted to address with the project is how can we design cooperative human-agent interaction in the context of smart charging. And for this, we first had to understand or get a better understanding of how can we assess or conceptualize perceived cooperativity in this context. And maybe in the end, there will be something like on the down right corner here. Maybe in the end, we will have something like an agent that monitors my behavior and then says something, okay, based on the data from the last 3 months, you need a maximum of 100 kilometers range tomorrow morning at 8 a.m. So is it fine if I set the charging to this or that? Okay, then let's make it very short when it comes to theory. So how do we conceptualize successful cooperation? So some of you may already know these 4 requirements that are often discussed and cited. And we thought in our context the 2 first are usually met, but we should go more into detail when it comes to directability and predictability. And if you look in previous research, then directability is often operationalized through the level of automation, and predictability you can operationalize it, and it has been done through the level or quality or amount of information you provide. And on the other hand side, you also need dependent variables. So what could be indicators for successful cooperation? So on the one hand side, it's kind of a user experience, so the perceived quality of the interaction or cooperation. So there are scales that assess perceived goal alignment. You can go for a system understanding, so users' awareness of an understanding of system information processing, so experienced information processing on quality. And you can also, of course, go into the core of what you want to assess and try to assess something like the perceived cooperativeness of the system. And of course, it's also always nice to have some behavioral indicator. So our 3 hypotheses were, first of all, that a lower degree of automation, so more autonomy, should increase human-agent cooperation or experience cooperativeness and behavioral indicators. then the amount of shared information, so more shared information, should help the cooperativeness experience. And in the end, people, or in settings where people perceive a higher cooperativeness, this should also lead to a general user experience. To answer also, so does it matter to invest in this cooperativeness experience? We also had an online study, 91 users. Many of them had already electric vehicle experience, not all of them, though it's not a very homogeneous sample. So there's a little heterogeneity in the study sample, and we used a scenario-based study with 4 groups. So low, high automation, low, high amount of information sharing. And as measures, we used the conflict subscale of the human machine interaction interference questionnaire, which is more from the automotive domain. We used the CIPA scale for subjective information processing awareness, and the perceived cooperativeness, self-developed, and for user experience, we used the common UEQ. And this was our scenario. So let's try to immerse ourselves. So imagine you live in the greater area of Lübeck. It's very nice there. In a single-family house, you own a PV storage, PV system, a private wallbox, and a battery electric vehicle. To charge your car at home, you use a smart charging agent. The agent supports you, ensuring that your car is charged with as much electricity as possible from your own PV system during each charging session, and so on and so on. And to do this, each time you plug in your car, you specify in an app when you need the car again and how much range you need for the next trip, and so on and so on. And now there's a scenario, okay, Friday evening after work, your remaining range is 15 kilometers. Next day you plan to leave in the afternoon at 2 p.m. because you have arranged a meeting with friends at Timmendorfer Strand. And so you plan a range of 100 kilometers, including a buffer for the trip. So that is something that you want to have. That is also specified because else we would need to go in all these topics about range stress, psychological range and stuff. And we didn't want this here in this study. And then there's first independent levels, the levels of automation. So we have one message variant where the smart charging agent in low automation level tells you some options and what they would mean. And then you have to change the charging window accordingly. And on the high automation condition, it just makes a suggestion, and you can object in the next 5 minutes. Then you have the charging interface, left the baseline interface, so to say, where you can change also, or the algorithm already pre-changed made a suggestion how to optimize the charging window, and you can already see this will become important what this means. And on the right hand side you not only have this result, but you also have the process how this result is computed. So when does the sun produce a lot of power, sun power on your roof, explaining how the figure on the left is in the end constructed. So I will go over this because of the time, and I don't think we need it really. Maybe this is quite interesting. So this is the very first shot, and we are continuing on this to have better scale conceptualizations of cooperativeness experience. And these are the results. So to start with, so is it indeed the case that a lower degree of automation and higher amount of information sharing leads to more behavior change, so acceptance of the change of the charging window, or self-change charging window? So we just looked at, do the people accept the change or change themselves? And what we found here is, and if you think about it for a while, maybe it may not be so surprising, but it was counter to our hypothesis. Maybe we made it a bit difficult for ourselves here, that indeed a higher degree of automation leads to rather more frequent prolonging of the charging window, so counter to our expectations. And the amount of information sharing was not a significant predictor for this behavioral indicator. And if you look at the user experience, so quality experience, then we can see there's not too much going on here. If you look at the p-values at the rightmost column, only, and this is quite interesting and also promising for the value of the ZIPA scale, so information provision versus subjective information processing awareness, in the sense of do I feel well informed and aware of how the system comes up, with its decision or suggestion. And here we see that a higher amount of information led to a better system understanding or better feeling of being informed, well informed. And does it matter? So is it worth to invest in this cooperativeness thing? Yes, it is. So perhaps interesting to start with, if you look at the ZIPA scale, then you can see that people who feel better informed, who have a higher subjective information processing awareness, also experience a better user experience, so in terms of attractiveness, pragmatic and hedonic quality. The effect is similar to even stronger when we look at the perceived cooperativeness as the core of the thing we want to access. So yes, it would be worth doing further studies, but maybe with an update on how we design our independent variables. So, but I mean, this was the very first study for us to go in this direction, and I think we learned a lot, and it's also worth it. But if you, for example, look at these contrary results on the top, that higher levels of information, higher levels of automation led to a higher probability of prolonging the charging window. This could be a domain thing, right? So because from where we drew our hypothesis from automated driving, there we can find this relationship. But of course, automated driving is more like, okay, you have been used to doing this manual for a long time, now it's taking away control. This may come with comfort, but it also leaves away some autonomy, or takes away some autonomy and maybe some feelings of pleasure and stimulation you can take from manual driving. And a charging agent is just a completely new task. But there is also another possible explanation, which is more like from the experimental design. It could also be, it's more like a status quo bias, that people are maybe also in this online setting moderately motivated to change something that is suggested. Yeah, so perhaps to keep the time short, then there are the classical limitations of online studies and the heterogeneity in the sample. But if you only looked at the people who had EV experience, it was not much different with the results. And we want to go into this further, for example, in our field lab, Renobile, where we can test bidirectional charging in car sharing settings in real life at University of Lübeck. So we built this up over the last 3 years, and now we are really looking forward to do research there, but also at the Honda Research Office in Offenbach, who also have such a similar lab as we have in Lübeck. So these are the references, and thank you for your attention.